Yeah.
Here we are. Back in our notes. Ready to continue our conversation. Remember, anytime you're doing a probability 5-card hand problem, your denominator will be 52 C5. So here we are, letter G. Denominator 52 C5. I want a 5-card hand with all of the aces. So I want a 5-card hand with all aces. I need to have all the aces in my hand. So what's your thought? What? Okay, now 4C5 isn't possible.
Because there's only
Wait, think about that. The first number, when I say 52C5,
because it's only 4 cards. If you
how
don't
many I
5
have to choose from,
yeah.
and this is how many I choose. So it doesn't make sense in any kind of problem to have 4C5. Does that make sense to you? Okay.
Because there's only 4 aces and you have only 5 cards in the hand.
Okay, so 4C4 would take care of all of the aces.
Maybe +1.
Now, wait a second. It says you have a 5-card hand with all of the aces.
Yeah. So then the
It
next
doesn't say they're all aces, it
1C,
just says you
52.
have all
Or
of the
52
aces.
C. No,
Close.
52 C2. 52 C.
No,
What? 1.
48C1.
Oh,
Because if I have a 5-card hand with all of the aces, that means I need one more card, right? And that other card will not be an ace, because I already have those. So there are 48 non-aces in the deck.
Yeah.
So this is gonna be a small one.
Picking up, putting down.
.5796.
Yep.
What did you get? 1.8. Yeah, 1.847 times 10 to the negative 5.
1.8.
1.8.
What is the probability being down to 5 per hand and 2 hands?
Yeah, Denise, this is
2 C4.
So denominator for the next problem, 52C5.
and
What's
4.
the numerator if I
2C4.
want 2 tens?
2 C4.
No,
What? 2 C5. Wait, what?
52.
4C2.
4C2.
Oh, I got mixed up.
There's my 2 tens.
And then 4C.
2 again. 4C2 again.
4C2
And then
again.
4C1.
There are my 2 jacks.
And 1 queen. So 4C.
4C1.
All over
And
52.
those are multiplied together, right?
Yeah.
That is all multiplied. Jacks and tens and queens. They are. You get 5 points. 541
Yep.
times 10 to the negative 5th.
Yep.
Is there a simpler way of putting that in your calculator?
It's just numerical. I mean, sorry, we're
For some reason,
arithmetic. It's
and
arithmetic.
I'm not sure why, Texas Instruments phased out the TI-85. I don't know why, because they make an 86, and they make the 84, and they still make the 83, but they phased out the 85.
They wanted to
And the 85 actually had a button right here in the top row, here, that you could do your combinations and permutations on. So I loved it for that reason. Don't make me anymore. I still have one. Okay. What are we ready for? I want a 5-card hand with no aces. There's my denominator. No aces, no queens, no fives. No aces, no queens, no fives.
So 4 minus 4 minus. I'm going
40.
Thank you. Thank you.
We did that one already with another problem. I don't remember what the answer was, but we did that one. Why is it 40?
Because
Because there's 12.
Because we took out the ones we didn't use, right? And so, that's the gift.
I don't remember. Oh, we did it for, Bill Face card. F. It sure was. 25.3% chance.
Okay,
Dana, can you pay attention?
now we want exactly 4
B. Use a B.
spades. So we want 4 spades. Okay. How many spades are in the deck? 13?
C4.
So 13 C4. Now be careful, how many cards are in my hand? 5. I only have 4. 4 more spades. What's the other one?
Anything.
Anything that's not a spade.
So it'd be 39.
39.
C1.
C1, that's it exactly. If you want exactly 4 spades, then 4 of them come from the 13 spades and the other one comes from the rest, right? So what's that one?
It's gonna be a really small one.
Bless you. Bless you.
Actually, that one, it's gonna be small, but it's not gonna be as small as some of the other ones I said.
Appreciate little bro. Little bro.
Dang.
No way, bro.
That's you in the way.
I actually got .0107, so .011.
I love that.
Anybody else get that?
Likely, that's likely.
Anybody else have that? Hey, stop it,
I did that.
okay?
Be nice, you could.
Did anybody else get that?
Yeah.
So you have about a 1% chance.
That's likely. 1 in 100.
All right, ooh, at least 4 spades.
So let's just do the other hand. So do.
So at least 4 spades would be 4 spades, or 5 spades.
Yes.
Now, this one we already did. This one's 13C4, 39C1, right? What's this one?
13C5.
13C5.
38. Wait.
39.
Oh, wait, no,
That's
that's
it, that's all
13.
5 cards
Yeah.
we've done. What would you do with these, since it's this one
Yeah, you add
or
'em.
this
You
one?
add 'em.
You would add them?
Yeah.
Now, Caitlin, this is a time saver. I would do my whole numerator and then just do the denominator once. They're both over that denominator, but you wouldn't have to type it in twice. Add your 2 pieces of the numerator together and then divide. It's not much different. I got .0112. All right. Everybody paying attention. L. What is the probability of being dealt at most 4 red cards? Now, at most 4 red. So what does that mean?
26 or
Yeah, 26 red. But what is that most?
Oh, we're going to.
You can't have
You don't want five, you don't
You
want
could
five.
get 4 red,
or 3.
or
Three.
3
Or
red,
two,
or 2 red,
you don't want more than.
or 1 red,
Or zero.
or no red.
Good.
Lordy,
Or
I
no
love what I heard over here. I think it was Elijah, because he's always talking. I think he said, you don't want 5 red.
Exactly. 13C4.
We want everything except 5 red.
Yes.
So what, back door, so what if we found the probability of 5 red and then took 1 minus that?
Yeah.
Would that give us
Yes.
everything else?
Yes. 1 minus.
Your
13C5.
option is you do all of these cases individually. Okay, it's a lot of
At
crunchy numbers.
Punching
So all 5 red
13C5.
will be 13C5
Over 52C5.
over 52C5.
And then.
That would, oh no, all red, 26.
Oh, 26.
Yeah.
26C5 would be all red. Is that okay with everybody? So let's just go ahead and find out what the probability of all red is. Okay, we want everything except that, so we'll take 1 minus that, and the answer is 0.975.
That's a really high chance.
Yes, but think about it, you could have, there's lots of possibilities. Basically, you want some reds, just not all reds.
Yeah.
So we have a 97.5% chance. M is tricky. Give me some thoughts about M. Give me an example. What are we talking about when we say 3 of one suit and 2 of another? What would that look
So
like?
3C13, or 13C13.
Well, it would be like 3 diamonds
Yeah.
and 2 spades.
Yeah. So 3C13.
Right.
Or 13C13.
Agreed? So what would that, let's say it was that specific case.
13C13.
13C3, my diamonds,
Plus. Oh, at the top.
times
13C2.
13C2, there's my spades, divided by 52C5.
Yeah.
So this is not the answer to the question. This is the answer to the specific question that says there are 3 diamonds and 2 spades.
But it could be. Yeah.
What else could it be, Ryan? Go ahead.
Like different suits.
Yeah, so it could be, I don't know, 3 hearts and 2 diamonds, right? Or 3 clubs and 2 spades. I mean, there are, each one of those different cases will be the same setup,
So
correct?
48.
So if I could figure out how many of those setups there are, I would just times it by that many.
There's 4 different setups. Oh wait, no. There's 8. 4 picker, right? This one is
16.
Maybe 24?
How many suits are there?
4.
How many are you picking for each setup?
2.
2. Does the order you pick them matter?
Yeah.
Yes,
Oh,
yeah.
yes.
3 and 2.
Why? Because it's 3 and 2. It does matter. If I were picking 3 and 3, then the order I picked them would matter. But since I'm picking 3 of the first one and 2 of the second one, the order I pick them matters, so it's 4P2.
4P2.
4P2. The first thing you gotta do is pick your suits. Which suits are you doing? Right here, this is how you pick them. The first one you pick is 3, and the second one you pick it's 2. That's why the order matters. Right to P.
That's one's a tough one.
That is a tough one.
So I kind of.
So let's see what the answer to that is. I'm kind of
I think
curious.
it's 0.1 out of 3.
Okay, could be.
Plugged it in the calculator. Plugged it in, you would have. Oh.
I did.
From somebody. Ooh. Oh, yeah.
I was talking to you.
He's not there, bro.
Like, you didn't even change even there.
Yeah, what would you call it?
Did somebody say .103?
Yep, I did. I got that.
Okay.
I know Sam said it. Come on, dude. Return to the trash disposal.
No, it costs me like that.
You guys are playing catch.
So about 1%
Alright.
chance.
No, that's a 10%.
Yeah, mine's
Alright.
10%.
10%. You're good.
How about you try to count?
Okay.
Oh.
If you look at your homework packet,
How about you try to catch
you will notice that there are 2 9-3 assignments,
Have your weekly.
okay? I'm assigning the first one. So 9.3, number 1, will be due on Monday, okay? Tomorrow we have our quiz over 9.1 and 9.2. 9.3, number 1 is due on Monday.
Oh, you think we're done? She can rest up for
But I don't want to do a Venn diagram. I want to keep doing
She
it.
can-
Okay, Sam, how long have you known me? A whole year, right? When was the last time I said, okay, let's just sit around and
Yeah.
chill? for
No. I said I don't know. I want to keep doing
We've
this.
known each other for only a year. I feel like I've known you for so many more. Like,
No, I'm saying I want to do the hard project.
All right, here we go.
We get one break.
I don't want to break. I'm going
You
to.
know, you just had a lunch break.
This is my favorite unit.
I don't like to take breaks. I like to just push through and get it all done.
All right, boys and girls, here's what's happened. There are 30 students in the class. I asked for a vote. How many of you like Twix and M&M's? And 6 kids said they like both. 11 kids said they like only M&M's. And 9 kids said they like only Twix. So we're gonna do some probability now with a Venn diagram, okay? Or answer some questions in a Venn diagram. All right, how many like M&M's?
17.
17.
Yeah.
There are 17 people in the M&M bowl.
Like in 15.
I hope you remember that when we take a quiz.
Mm.
How many like only
11.
11. 11.
Yeah, I'm reporting.
How many like M&M's and Twix? 6. How many like M&M's or
20.
Twix?
6.
26.
26. 26. Why is it 26?
Because you have them both.
Because everybody in there likes one or the other, right? Now, some of them like both, and that's okay, but they like one or the other. How many like only M&M's or only Twix? That's 20. How many like neither? 4. And we know that because there's 26 in balls,
And there's 30.
but there's 30 total, so there have to be 4 people out here.
Yeah.
Now, this isn't on the sheet, but it's coming, let's make sure we get it. Let's suppose, here's my class of 30, I reach in blindfolded and grab one. What is the probability that I'll get a kid who doesn't like either candy?
4 out of 30.
4 out of 30. And I would reduce that, but
Yeah.
yes, 4 out of 30. So, what's the probability I'd get a kid that likes M&M's?
11.
No, M&M's.
17 out of 30.
17 out of 30,
It's like
right? So we could easily turn this Venn diagram into a probability question. Your denominator would be 30. Okay? All right.
Even though like Twix, that's a 50%.
There are 28 kids in the class. So here we are, 28. They either like jazz or country. Or both. Everybody does, okay? So there's 0 out here, all 28 are in the bowl. All right, so I took a vote, and 18 kids liked jazz, and 14 kids liked country.
Mm-hmm.
Yeah.
Now wait, I have a bit of a problem here.
32
That's 32, so when I voted,
Yeah.
32 hands went up, but there's only 28 kids in the class.
So some of them are both.
So how many?
32
were
out of
twice?
28.
4 voted twice.
Oh, okay. No, you're good, Ryan.
Everybody in the class voted. 32 hands went up, 28 kids, 4 extra
So
hands,
14 jazz.
right? Since the whole jazz ball is 18, this part must be
14 jazz.
14,
You're good.
and this part must be 10?
Yeah. Very good boy.
How many students like only jazz?
18.
Only
14.
jazz?
14 now.
14, right? So again, turn this into probability. What's the probability I choose a kid that likes both?
50%. Oh.
4 out of.
Right.
I thought we were answering the question. I thought we were answering the question.
Oh, no.
Another look. I had to look.
All right, now here are things gonna be a little
That was
easier.
clean though.
Here we go.
I got it.
There are 32 kids in the class.
Oh, that's bad.
They like Fords, Buicks, and Chevys. 19 like Fords, 19 like Buicks,
Should we draw this?
and 12 like Chevys.
Should we draw this one bigger?
Yeah.
Yes.
it's fine.
Mike, come
Can you
on.
be nice to me, Velosto? Gee.
Now, please note that just like the last problem we did, when they say jazz is 18, I didn't put 18 in my picture. Because jazz is the whole ball, and it's divided into 2 sections, right? So, similarly, there may be 19 people in the F ball, but they're divided up in these 4 pieces, right? So none of those numbers are going into your circles. 5, like all 3. That can go in there, right there. Would you agree with that? 5, like all 3.
Yeah.
6, like only 4s. 3, like only Buicks. And 2, like only Chevys. Are you okay with my placement of numbers?
Yes.
What is the probability that if a student chosen at random, he'll like both Chevys and Buicks? Okay, now wait a minute.
You don't have that.
I can't answer that question until I fill in some blanks. So I'm gonna call this X, this Y, and this Z. Because those are the 3 parts of the Venn diagram that I don't have information for. You with me?
Mm-hmm.
Okay, so
Which one is
now,
50?
I know that X plus Y plus 11 is 19.
Yes.
Now wait a second, the whole F ball is 19.
Yep.
So 6 and 5, X and Y have to add up to 19,
Okay.
right? Which means that X plus Y is
Equals
8.
8.
I'm gonna go ahead and write that over the side. Now, let's look at Buicks. I know that X plus Z plus 8 equals 19. Those are the Buicks. I got a 5 and a 3, an X and a Z.
X plus Z was 11.
So X plus Z is 11.
Okay.
And then the Chevys.
And then we do 6
Y plus Z plus 7 equals 12.
So Y plus Z was 5.
So Y plus Z
Okay, we can just like do it off that. We can find out.
now.
Okay.
Are you still with me?
No.
What's the matter, Tyler?
I got it.
You got it. I'm just adding up the numbers in the circle until
Yeah.
we get to this.
I forgot where the 5 was at.
Okay. Now, this is a system of 3 equations, 3 unknowns. Now, the good news is, all of the equations only have 2 of them. So here's what I suggest you do. You do whatever you want. You could certainly set up a matrix and do this with a lot of zeros in there. I would say, I'll just take these 2 bottom ones. If I multiply this by a negative, then I will lose my z's. So I will have x minus y equals 6. X minus y, these will be gone, equals 6. Agreed? Now I compare that one with the top one. You see what's going to happen? 2x equals 14, so x equals 7. So I come up here and put a 7 here. Now remember, the whole F ball adds up to 19. So I got 18 right there, don't I? Which means y has to be 1?
Yeah.
Now I have 2 and 1 and 5 in my Chevy ball. So it looks like Z has to be 4. And now I can answer my question. So I'll fill it in.
So but if you plug them back into those
Yeah, you can
equations,
still plug them back in, absolutely.
would they work?
Yep.
Okay.
So what was the first one I found? X was 7, so put 7 in here, Y has to be 1. I just did it with the diagram, but you can do it here. See how easy that was?
Yes.
So again, my suggestion is, take 2 of them and get rid of their common variable. Whatever you have left, you can match up with your third equation.
Chevy Buick. So more Chevy Buick is 4.
Alright, where are the Chevys and Buicks?
4.
Oh, no.
That's 9.
Oh, no.
It's 9.
Chevys and Buicks are
That's
right
9.
here.
Yeah.
It doesn't say
No,
only
4.
Chevys and Buicks.
Yeah,
It
it's
says, did you vote for Chevys? Yes. Did you vote for Buicks? Yes.
Yes.
Now, did you also vote for the other thing? Sure.
Yeah.
Don't care. You like Chevys and Buicks. So 9 of them like Chevys and Buicks.
4 students in it.
Who likes nothing?
4.
How did you get 4?
You add all the numbers. You add up all the numbers.
You add up all those.
And there's 32 total.
Back from 32.
Bang.
Do these make 28?
Our kids are so interesting when you know what to do.
Yep, they do. So 4 kids. Why are you packing up?
Wow, yeah, what are you doing?
We don't have enough time for another problem.
You have enough time to start another problem, Joe?
Honestly, bro.
And to think that you were her favorite student. You should think that.
Yeah, there's nobody really talking about
Alright.
Dana, where you at? Dana, where you at?
In a month, you guys aren't gonna have the pleasure of being in this class anymore, so let's enjoy everything.
Let's enjoy every
Enjoy our present.
Let's get the Venn diagram.
Hey, you too.
Why you like it.
Zip it.
Here we go. We've got green, we got 68 kids, we got green, we got purple, and we've got yellow. Alright, so let's fill in what we can fill in. We won't do the equations, so let's fill in what we can fill in. 6 like to all 3.
43 like green.
23 said they, oh wait, 11 like only yellow. 15 like only green. And 4 like only purple.
Oh, okay, I see what you're
So
saying.
would you agree that that's all I can fill in right now?
Yes.
But that's all given. So tomorrow, we will write out some equations and solve them, just like we just did.
Okay. All right, sounds good to me. We have a quiz. Our quiz. Oh my god, I like it.
What?
Over 9 going on to practice at the beginning of the period. Don't act surprised. Oh my God.
And this is 5 quiz. We have time to
Oh, this is 4.
I was on time yesterday.
So say we have homework due, say like tomorrow.
Obviously, I won't be, but like, I was saying 16, and the homework's due. I have emailed
I miss it tomorrow.
I actually, yeah, me and